interest. Let's see how simple it is. Well, it's based on a formula that we're going to use a lot. Here it is. The I stands for interest, and interest is an amount of money, okay? This is the amount of money that's a fee charged for using other people's money, and it gets charged when you borrow money or when you invest money. Principal is the amount that you invest or borrow. Rate is the percentage that's used in the calculation. You're going to change it to a decimal. And time is always calculated in years. This is the amount of time that the money is invested or borrowed before it's paid back. These aren't very complicated problems, but that's not why it's called simple. There's two kinds of interest calculations, and we're going to stick to what's called simple interest. But I wanted to quickly explain to you the difference between simple interest and compound interest. It has to do with how interest is calculated on a yearly basis. In simple interest, you calculate the amount of interest on the same principal. You never change the amount of principal. It's always based on the original amount. But in compound interest, every year you take that principal and you add whatever interest has accumulated so far before you calculate again. So now you've got a bigger principal the second year to calculate the interest, and the interest will be greater. Then at the end of the second year, you add that year's interest to the principal, and so you see the principal keeps getting bigger and bigger that you calculate the amount of interest. And so if you look at this blue line, that's why the amount of money invested or borrowed is increasing over time so much faster. It's because the principal grows as time goes by. Whereas with simple interest, the principal stays the same all the time. Okay, let's try solving a problem using this formula. So how much simple interest is owed on $5,000 if borrowed for 7 years at 5%? $5,000 is the amount borrowed, that's the principal. 7 years is the time, and 5% is the rate, which we're going to change to a decimal. So let's plug all those in. So the interest, which is going to be in dollars, is equal to $5,000 times 0.05 times 7 years. So just calculate that. The interest comes out to $1,750. Now remember, that's just the fee that gets tacked on for borrowing $5,000. What is the maturity value of the loan? That means at the end of the loan, how much money did you really have to pay back? Because you borrowed $5,000, but over time you accumulated some interest and you have to pay that back also. So the maturity value is all the principal plus all the interest over time. And for this loan, you're going to end up paying back $6,750, even though you were borrowing $5,000 that you got to use. And that's how loans work. Let's try another problem. Keep in mind what the formula is and look for all the parts. Okay, PJ got a $1,200 loan for 2 years. She paid $90 in interest. What was the interest rate? So our variable is going to be R. 2 years is clearly the time, and $1,200 is the amount of the loan, so that's the principal. $90 in interest. So this time we know the interest, but we're looking for the rate. So go ahead and plug in all the parts you know. We know that $90 is equal to $1,200 times 2 times R. So just simplify and solve for R. So the rate is 0.0375, and as a percent, that is 3.75%. Okay, let's plug what we know into our formula again. How much money was invested? So this time, we're actually missing the principal. At 6%, annual simple interest for 3 years to earn $3,870. If you're earning that amount, that's the interest. So remember the formula, I equals PERT. 3,870 is equal to P times the rate as a decimal times the time. So we can simplify and then solve for P. Divide both sides by 0.18. So our principal must have been $21,500. You must have invested $21,500 at 6% for 3 years in order to earn this much interest. And that's how you use the formula. So go try some of those.